Hi, this is Chris Schomburg, and we're using Tinkercad in this case to go ahead and start our first lab. And our first lab right here is actually how a resistor works. Now, we've learned a little bit about electronics. We've learned that the flow of voltage is somewhat of a potential difference. And so that's a lot like the potential of water flowing through a dam. And that's the voltage. It's a potential difference. And then the current is actually like the flow of a stream or the water. And to tap into that, typically we want to actually have a resistor in series with an LED. And why we do that is so we don't blow up our LEDs. Now, one thing to note is that this is the positive side of the 9-volt battery. This is the negative side. We denote that with a red and for positive and a black for negative. Now, the key thing here too is that the circular side of our LED is always going to be the positive side, and the long side or the flat side is always going to be the negative side. Now, typically, if you're actually working with an LED, the long end is always going to be the positive, and the short end is always going to be the negative. So that's kind of key. However, if you're doing any type of work where you're using old materials or recycled materials or salvage materials, you're going to always need to remember the circular side and the flat side. Again, the circular side is the positive, the flat side is the negative. So let's look and see what not to do first. Let's say we actually take this LED and we just put it directly on the leads of the positive and the negative. And we get a really brilliant light telling us is actually the current through here is 0.9 or almost 1 amp, while the maximum should only be 20 milliamps. So saying you have a high current, it's going to burst. It's going to burn out the LED, or worse, it'll pop. So I'm going to stop the simulation. We're going to go ahead. We're going to do this. We're going to actually put it in a circuit. Now, I'm going to put it in A1 and 2. To do that, I'm going to rotate it. So I'm going to rotate it this way. Okay. Now remember, the circular side is always the positive side. Okay. And the flat side is always the negative side. Now, this would work perfectly if I went from A to the positive rail, but I'm not going to. I'm going to move it into B then, 1 and 2. Okay, just so you can see there. But that's not going to work either, so I'm going to go all the way down to D, 1 and 2. And the reason is that this is because then I can actually put 1 to the positive rail. Okay, that's a jumper. We call that a jumper. Now we can actually color it red because that's the positive jumper. And then we can go ahead and we can go from E all the way to the negative rail. And I'm going to make that one black. There we go. So now what we're going to do is we could get fancy, and I'm going to get a little fancy. I'm going to rotate my 9-volt battery so it's up top here like that. Okay. Now I have a positive, so I'm going to go out a little bit and I'm going to go over right here, and then I'm going to go down. Okay. Now, what that's saying is that this is all positive right here, that's all positive right here, going through here to the negative, and then we have to hook up the negative. So we're going to go from the negative, and I'm going to go out a little bit, and then over, and then down, and I'm going to color that one black. Okay, so now we should have a circuit, a loop, basically, of how this works. This is basically a loop of a diode working. Now, we have the exact same circuit that we did before with just putting it to the leads. And we should see the same result, a very, very bright 1 amp current, which could either pop the diode or break the diode or somehow destroy it. Not a good thing. So the first thing that we learn about is called a resistor. This is a resistor. It resists the flow of the current. Much like pebbles in a stream, it's going to actually resist that current, and it's actually going to reduce it, so that we don't have such a high current, so we're not going to have as much of a problem. So I'm going to put it where this one is right here, this black resistor, or the ground lead is. So to do that, I'm going to go ahead, I'm going to delete it first. And I can't put it like that because that's going to short it. So it's going to rotate. There we go. So now what we're going to do is I'm going to go from here to negative. Notice these are in horizontal. They're all connected. So I'm going to go from the negative down to here. And I'm going to go from the negative here, the end right here, to the black, which is to the ground right here. Now this time it should light up, but it shouldn't be as brilliant. Okay, there we go. And so that is actually a working diode. This is going to actually work as a light. It's going to work perfectly. And we're not going to have any diodes that are going to blow up this way. Now, I just used the basic resistor. What is this resistor? What is its value? It's actually 1 kilo ohm resistor. And that's typically what we use with a 9-volt battery, because that reduces our current flow to something that is less than something that would be dangerous. So it reduces it and it limits the current, so it's not something that's dangerous not only to you, but also dangerous to the circuit or to the breadboard. Okay, so we can change this resistance value. Typically, there's a lot of different resistors that you should have. You should have a 100 ohm. You should have a 220 ohm. You should have a 1K, which this is, and a 6.8. So let's start with a 6.8 kilo ohm. Okay, it should be a blue, gray, red, gold. That's how we read it. Blue, gray, red, gold. Now the key thing here is if we look back, at our experiments, there are ways to actually read and denote how each resistor looks. And so the first thing you're going to see is the first one right here, this blue, indicates it actually stands for a number, and then the gray stands for a number. The red right here is actually going to stand for a number as well, and then the gold is actually a tolerance. It can either be silver or gold. Gold meaning it's 5% tolerance, and silver meaning it's 10% tolerance. So the first band actually represents a number, okay? And the second band actually represents a number, and the third actually represents the number of zeros, okay? So the fourth band then is the tolerance, either 5% or 10%. Again, gold being 5% and silver being 10%. Now, usually you're like, well, it's bigger. That means that it should be better. No, we want the tolerance to be as little as possible percentage-wise, so that it basically, it's like the slop. It's like a slot. If you're to cut it, you want it to be as small of a slot as possible. You want it to be as close to 1% as possible. And so 5% is actually better standard. It's a gold standard versus a silver being a 10% standard. Okay, so what does the color code actually mean? And how do we actually read this color code? That could be a really good question. So so typically, if we look at that, what that means is we could actually find a color code thing on the internet. So I can say color code Okay, so you can actually have a resistor color code calculator, and that will actually work the best for us. And so if we look back, we were looking at resistors, right? So the first one, remember, was a blue. The second one was a gray. The third one was a red, and this tolerance was a gold. Okay, so really, you can actually just plug these in, which is really nice. When I was a student like you guys, I actually had to look at a chart, and the chart would tell me exactly what it was. So right here we can see this is 6.8 kilo ohms. Now how we know that and how this works is this is 6 right here is the blue, the gray is the 8, okay? So 6, 8, and then we have times 100. So 100 would put this at 6,800, and then the tolerance is 5. So that's how we get 6.8 kilograms, or kiloohms. I said that wrong. Kiloohms. So 6.8 kiloohms. And why we know this is because kilo is times 10 to the 3. So we go, this is 100. So then this is the third digit right here. So this is the thousandths digit. So 6.8 kiloohms and 5% tolerance. Okay? So that's the first one. Let's go ahead. Let's change it to the next one. So that one right here, we're seeing it's not very bright right now. Okay? So let's go ahead. We went to our 1K. So that's the simplest one. That's what it comes with. And really a 1K resistor actually is a brown. Okay? It is a black. It is a red gold. Okay? So this is a 1K. And how we can see that is because we have 10 times 100 is going to give us 1,000, which is 1K. Okay? And then the gold standard again for the tolerance. Okay. So let's go to the next one right here. Okay, so let's go ahead. Next one was a 220 ohm resistor. Now we can change the kiloohms to mega ohms, giga, down to ohms, milliohms, micro ohms, nano ohms, pico ohms. What we're going to start with is right here, which is just ohms. So this is 220 ohms. So notice this is a red, red, brown, gold. So let's go ahead and type this in as a red, red, brown, gold. Again, it's 222 times 10, which is 220 ohms. And this is a 5% tolerance, which is a gold. Okay, so that's how we get our 22 ohms. 220 ohms. I said that wrong. So 220 ohms in this case. So this is a lot more brilliant. You can see it's a lot brighter. Okay, could be. It's not dangerous. You're not going to be burning anything out with a 220 ohm resistor, but it can. You're getting closer to a lot higher current going through. So it's allowing, kind of like a valve on a hose, it's allowing more current to flow than the first ones. So let's go down to the lowest setting that your book recommends, which is 100 ohms. Okay, so if we look at 100 ohms, again, we see that that's a brown, black, brown, gold. So let's look here. So if we look here, we see a brown, black, brown, gold. Okay, which is 10 times 10, which is 100. It's 100 ohms, and that's a 5% tolerance. Okay, so that's 100 ohms, which is a 5% tolerance. Okay, so really what we've done then is we have actually looked through and we've actually seen all the resistors that they suggest for this circuit, and we've been able to actually create a circuit that actually powers by a battery and then uses a resistor to limit the current and allows a diode to go ahead and be displayed. Now I'm going to stop really quick here and I'm going to show you, let's say we rotate that LED all the way around, and note this is not the way you want to put an LED. We start it, again, you see nothing happens. Well, that's kind of a problem, right? So LEDs only allow current to flow in one direction, and we'll learn about something like that later, which is called a diode. And actually, LED represents a light emitting diode. So it is a diode, and it only lets current flow in one direction. Now, later in some of the kits that I actually have two different light emitting diodes. So I have one, see if we can change the color. Okay, yeah, so there are other LEDs that you can actually select in Tinkercad and in the basic circuits. If we go into all circuits and we go into LEDs, okay, so we should be able to get all kinds of different LEDs. I guess for this sake, I was hoping they would just have a different color, but they have this one right here, which actually can be multiple colors. Okay, so it can actually be multiple different colors, and so we could use this one too to do something like what we've done here. But what we'll do is we're going to just duplicate this one for now. So I'm going to go ahead and I can actually use my Control C and Control V, and I can use that perfectly. Now I can rotate this one this way, and so now we have one. I can put it right here. I can put this one right here, and so now if I put it in, I have one LED that works and one that doesn't, and that's because they're in opposite directions. I was hoping to do different colors. Unfortunately, I'm not seeing. See if they have a green. I am not seeing a green LED. Okay, so that being said, so let's go ahead. I know I've done it in the past, but I guess we can't do it here. So what I'm going to do here is I'm going to cheat, and I'm going to use the multiple color LED for the same reason. So I'm going to stop the simulation. I'm going to pull this one out, and I'm going to put this one in instead. Okay, so here we go. So this is the green, this is the blue, this is the cathode, this is the red. Okay, so we're going to go ahead, we're going to put the green right there, and then we're going to put the cathode right there. See if it works. There we go. It works, and it's a green LED, so that is good. But the key thing here is it is actually short-circuiting. Okay, I think that's just because of the way this LED is designed. I'm actually short-circuiting because I'm hitting this blue LED there. So I think if I go ahead and I put this in, just like that. Let's color code this a little bit if I can. It's not going to let me right now, huh? Alright, let's try. That is silly. Okay, it's being silly, but that's okay. Let's start the simulation now. It's also shorting. So why is that? We might think about this, and we might just say, okay, let's just click on it and see what's going on. Well, it has, right now it's 70 milliamps, or about 80 milliamps, or 71 milliamps, and it can only allow 20 milliamps. This one before could allow more. So this is a more sensitive LED. So in doing that, we know then that the 100, the brown, black, brown, gold resistor is too small. So let's go ahead, stop the simulation. Let's change this resistor. Let's go one step up. Boy. Now it's not letting me change the resistor. That's so silly. Alright. There we go. I don't know why it's being so silly. So it'll probably let me change the color too now. Yep, it will. So let's go ahead and let's put this one as a black. And let's put this one as a red. There we go. So somehow just kind of glitches in the system. Okay, so what we can do, we can actually change these colors too. That's way nice. Okay, so we could, so we'll just test a theory. So let's go ahead, let's go up one step. Okay, so we had 100 ohms. Let's go 220. There we go. Let's start it. Still too high. How high is it right now? It's 32 milliamps, so still too high. So typically we don't want our 220s, so it could be kind of dangerous to use 220s. So if we go ahead and we move this up to 1 kilo ohm, right? That's 1 kilo ohm. Then we start it. Hey, both lights work. We have a green light, we have a red light. Now, I can make this even easier. Well, let's just, for fun, let's just kind of play around with this LED because it is a fun LED to play around with. Okay, so right now we have it as green, right? Let's go ahead and let's put it right here as blue. Start. Now we actually have a blue light and a red light. Isn't that pretty cool? Pretty nifty. Okay, we can do one other color. We can do red. We start it, we get a red LED and a red LED. Okay, so now let's actually take it a step back to where we were before we played with this nifty LED. Okay, and let's go ahead and let's just put this one in the opposite direction. Let's call this one green, and for fun, we're going to keep that one as red. We can go like that. Now the green one is working, we're good there. Okay, we can also change this one to another color. So we could change it to a blue. We could get a blue light. There's all different kinds of colors we can use. We can use a yellow. There we go. We can actually go to an orange, which is actually very hard to come by. Just price-wise, they're kind of hard to find. And then a white. Sometimes you don't want white because you could be easily confused with an infrared. So that's a key point. Okay, so what we have learned about really in this project is we've learned about how a resistor works. Remember, it limits the amount of current flow in a circuit. Okay. The other thing that we need to keep in mind is we need to keep in mind the schematic symbol, the drawing schematic, and some of those other things, and I will look at that in a second here. But first, before we do this, I just want to make sure you realize that as you progressively move from higher resistance, the brightness on the LED actually decreases. The flow of the current, therefore, and the brightness of the LED decreases as the flow of current decreases. Okay, so as we increase the resistance, we decrease the brilliance or the luminosity of that LED. Okay, so that is really just lab number 1. So as you increase the resistance, the dimmer the LED should appear, and that's what we actually found. We found that with several different resistors. Again, we did that with a 100 ohm, a 220 ohm, a 1K ohm, and a 6.8 kilo ohm. So that's basically what we used. Okay, so what we're going to do is we're going to actually make a drawing, and I actually have a whiteboard here that I can look at, and I'm actually going to do a full screen snippet. So we're going to see our full screen that we had before. We're going to then draw kind of the circuit that actually this represents. And so to do that, I'm going to actually use a tablet. It is a graphics tablet to be able to draw. So what we're going to look at right here is really there's 3 different types of things that we're really looking at here. And okay, so really what we see here is we see a positive, negative, positive, negative. Okay, so what we have then is that is a positive and negative terminal of a battery. That is the schematic for the positive and negative terminal of a battery. Okay, and basically we then have a resistor and we have an LED in the circuit. And that LED looks something like that. Okay, so really essentially we have three different elements, and I'm going to actually color code these so that you can see what is actually coming up and what they actually look like. So the first one, I'm going to go ahead, we have a battery, so I'm going to do kind of a flesh tone for that. So I'm going to draw a circle around this guy. Okay, this is number 1. And this is number 1. Right here. Okay, that's our battery. Notice this is the positive, this is the negative. And I can actually do that in a little bit different color real quick here. So this is the positive. And let's go ahead and change the color. This is the negative. Okay? So positive and negative. Okay? Now, the resistor is an interesting device because it honestly doesn't matter which direction we have it. So this is our resistor. This is number 2. And our resistor right here is right here. Doesn't matter which direction we have it. Okay? And then the next one is very directional. And I'm going to actually go ahead and put this one as a orange. Okay? So right here, this right here is our diode. And these two are both of our diodes. Okay? And so this is our symbol. So what we're looking at here, this is our symbol diagram. Okay, so this is our schematic diagram. Okay, and the key thing here is this right here is actually the symbol. So both of these are actually schematic diagrams. But we call this one right here, we call it the symbol or symbolic. Okay? And then this is actually the appearance. This is closer to an actual appearance schematic. Okay, so that's kind of the difference between the two. So, that being noted, let's just go over these one more time. So number 1, this is our battery. Again, this is the positive and the negative. This is the positive and the negative. This right number 2 is our resistor, right? That's our resistor. It doesn't matter which direction it is. The resistor works well either way. And this is a symbolic diagram right here. And then what we have here is number 3 is our diode. Okay? And our diode really does depend on which direction it is. So in this case, in this course, what I'm going to suggest you do is you put one diode one way, one diode the other way, and then you know that you have one that will work in this case. And so that should work either way. So that's kind of the goal. This is just the symbol for one of those diodes, and it's in the right proper direction. Okay. Now, if we're not going to talk about the diodes too much here, we'll talk about that in a later session. So later we'll learn about which direction you draw the symbol and which direction you put this diode in. But for now, this is our first lesson on resistance, batteries, and LEDs. All right, hopefully you enjoyed it, and hopefully you learned a little bit more about the basics of electronics.